Let's now learn about methods of circuit analysis. And of course, this is related to DC analysis right here. And there are mainly four kind of techniques or methods that you could use to analyze the DC circuits. The first step, in this tutorial, we are only going to learn about the source transformation theorem, but the other three techniques or methods are referred to as Thevenin's and Norton's theorem, superposition theorem, and lastly, we will cover nodal and mesh analysis. Remember, in this video, we are only going to learn about source transformation, and in the next video, we'll learn about Thevenin's and Norton's theorem. So what is source transformation theorem? Okay, so let's go through some of the definitions here. Thevenin circuit. What is a Thevenin circuit? It's a voltage source in series with resistor. So in other words, basically, it is just a circuit with some source and resistance. And we refer to this resistance as the Thevenin resistance. These are the two folks who came up with these theorems, the Thevenin and the Norton. So this is Thevenin circuit right here. The source is referred to as Thevenin voltage right here. Okay. The second one, which is the Norton circuit, oops, that is the current source is in parallel with resistor. Okay, so instead of a voltage source, you have a current source here, and then it is connected to a resistance in parallel with it. Okay, and this is just, open terminals right here. Okay, so maybe this could be like V out right here, or you can have some kind of load connected over here, RL. Okay, this is just imaginary. Okay, so again, this will be referred to as the Norton resistance right here, and this is the Norton current right here, INO in the subscript. Okay, all right. Now, so Thevenin circuit basically takes this from right here, okay, and then the Norton takes Norton circuit takes this from right here, where you have the current source in parallel with resistor. So why this is source transformation technique or theorem? Why it is referred to as source transformation theorem? The question that may come to your mind. Well, the answer is this is the method that allow us to easily convert between these two types of circuits. Okay, so if you have a circuit which looks like this, you can actually convert this circuit into something that may look like this. Okay, and similarly, you can do it vice versa. Okay, if you have a circuit like this at the bottom, you can convert it to something like that you see over here at the top. What is the conversion process? And again, source transformation allows the simple transition between these two circuits. Okay, so what is the conversion process then? What is the conversion process? Well, if you look at the two circuits, the RTH over here, okay, the RTH and the Norton resistance, they are going to be same. Okay, so your RTH equals to the Norton resistance, and because they are same, so I can just refer it to R resistance, so it will be easier for us. They basically have same values. Okay, if you have a Thevenin circuit over here, you can actually calculate the Norton current by using just simply Ohm's law, where V would be the Thevenin voltage and resistance will be the Thevenin resistance of the circuit. Okay, so you get current, Norton current. Similarly, if you have a Norton circuit over here, then you can calculate the Thevenin voltage by simply apply Ohm's law, where Thevenin voltage is equivalent to Norton current times R, which is the RTH. Or remember, RTH, RNO, they all are same. I can just probably go with R, not say RTH. Okay, so this will be just VTH over R, and then this is I Norton current times resistance. Okay, cool. Okay, next. So let's say I have a Thevenin circuit. Okay, and the circuit looks something like this. I have a resistance in series. Say this is 1 kilo ohm. This is a battery right here. This is rated as 5 volt. Okay, remember this is a Thevenin circuit right here. Okay, and the goal would be to convert it into a Norton equivalent circuit. So I can calculate the Norton current, because in order for me to convert, I need to find out the Norton current, which will be VTH over R. VTH is 5 volts here, okay? And then R is 1 kilo ohm, so I get 1 kilo ohm here, which means Norton current will be 5 milliamps, right? Okay, so the transformation would look something like this. So you'll have a current source rated at 5 amps. You will have the resistance in parallel with the source. Again, this will be R, and then these open terminals right here. Okay, so basically you have converted this circuit into something that is equivalent to this circuit right here. So that's the source transformation theorem.